Have you ever wondered why this Rubik's Cube, which is often considered as a children's toy, fascinates the mathematicians too? Surely because there is too much mathematics involved in it. In this video, I'll try my best to give you a good idea of all that is there, including the minimum number of moves required to solve it, the total number of possible permutations, and a lot more. So let's get started. What if you take a Rubik's Cube and separate every piece of it, and then you close your eyes and start assembling it again in any preferred configuration? When you take the first corner piece, you'll have 8 possible positions of putting it, as there are a total of 8 corner pieces in the cube. Then for the second piece, you will have 7 possible positions, as one position has already been occupied by the first piece you have put. Now for the third piece, you will have 6 possible positions, and so on until for the last piece you will have only 1 position left. So when you multiply them, it becomes 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, or rather simply 8 factorial. And each piece can be arranged in 3 possible orientations. It gives us 3 to the power 8 possibilities for each permutation of the corner pieces. Now coming to the edge pieces, there are in all 12 of them, giving us 12 factorial ways of arranging them, and in addition to it, the 2 possible orientations of edge pieces give 2 to the power 12 possibilities for each permutation. Calculating all of the above expression gives us a total of this number, or simply 519 quintillion. Out of this 519 quintillion possible arrangements, not all permutations are possible. Only 1 in every 12 of these are actually solvable. This is because there is no sequence of moves that will swap a single pair of pieces or rotate a single corner or edge piece. These 12 possible sets of reachable configurations are often called as universes or orbits. Dividing this number by 12, it comes down to this number, which is approximately equal to 43 quintillion. This number is the maximum number of possible patterns in the cube that can be solved using the regular algorithms. Mathematically, Rubik's Cube is a permutation group because in math, a permutation group is a finite group G whose elements are permutations of a given set and whose group operation is composition of permutations in G. There are certain simple properties of this mathematical structure, but for understanding this, you must know a certain set of moves on the Rubik's Cube. When you move the rightmost layer of your cube 90 degrees in clockwise direction, it's termed as the move R. The same move in anti-clockwise direction is R dash. Similarly, when you move the leftmost layer of your cube 90 degrees in clockwise direction, it's termed as the move L. The same move in anti-clockwise direction is L dash. A 90 degree clockwise turn of the uppermost layer is U, and 90 degree anti-clockwise turn is U dash. The same is for the bottom layer. 90 degree clockwise turn is B, and anti-clockwise turn is B dash. The front layer facing towards you when makes a 90 degree clockwise turn is F, and when it turns anti-clockwise, it's F dash. And the back layer facing away from you makes a move B by turning 90 degrees in clockwise direction, and a move B dash in anti. The properties are: first, associative. This property states that the permutations in the row can be grouped in any way. For example, the move RU R dash is exactly equal to the move R U R dash. The second property is neutral element, which means that there is a permutation which doesn't rearrange the set. For example, when you perform a move R followed by the move R dash, you restore your initial configuration. The next one is inverse element, which is quite intuitive. This states that for every permutation, there exists an inverse permutation. For instance, the move R has its inverse as R dash. And last one, commutative property, which is rather not a property here because it's sometimes true and sometimes not. Like the move PF is exactly the same as FP, but FR is not the same as RF. Now the next important part, the God's number. Don't worry, it's not something related to God, it's just a name given to it. This number is the maximum of the minimum number of moves required to solve any of the 43 quintillion combinations of the cube. And since July of 2010, we know that this number is 20. So every configuration can be solved in 20 moves or less. This has been given the name God's number because it was initially thought that only a superhuman could do it, so somehow related to God. So that is all I had to tell you. If you want to dig deeper into the topic, then do check the links I gave in the description. Thank you.